Welcome to queenon7.com. Today we're going to learn about the pH. There are some more videos coming up to cover the whole topic. The property of an acid is actually dissociate into its ions. Now, if you have a strong acid, it will completely dissociate into H positive ion and the rest of the negative part of that acid. If it is a weak acid, it is the whole molecules present in the solution are not going to dissociate into positive and negative ions. Only a tiny amount of it will be dissociate, depends how weak acid it is. Now, if you look at the pH, to find out the pH, your primary focus is to get to the H positive ion concentration. If you don't get to H positive ion concentration, there's no way you can actually find out the pH. Now, the pH can be calculated by taking the minus log of H positive ion concentration, which is going to be in the moles per dm cube. So your focus in the whole question, either it is related to acid, base or buffers, you have to get to the H positive ion to find out the pH. Now, if you have been given a pH and they're asking you to calculate the concentration of H positive ion, then you have to actually reverse everything. So H positive ion concentration, you do the anti-log of the pH, and this is how you're going to find out the pH of the concentration of H positive ion. Now, the strong acids, they completely dissociate into the solution, so they will make equal positive and negative ions once they are actually dissolved in the aqueous solution. If you look at the pH of a strong acids, I can take an example of a 0.1 molar solution of HCl, which is going to be dissociated into H positive ion plus Cl negative ion. So completely dissociated into its ions in the aqueous solution. Now, if I want to calculate the pH, the formula is minus log of H positive ion concentration. I do know that the concentration will be both are same. So that means if you have 0.1 molar of HCl, it will produce 0.1 molar of H positive ion and 0.1 molar of chloride ion. The pH is actually because of the H positive ion. So what we're going to do is we're going to say the pH is equal to minus log of H positive ion concentration, which is actually minus log of 0.1 molar solution. Because it's a balanced equation, so there is no coefficient. If there isn't a coefficient, you can put actually the raised to the power of the concentration of H positive ion. Next part is the ionic product of water. You do know that water can be dissociated into H positive ion plus OH negative ion. Because it's a poor dissociator, not only tiny a fraction amount of the water molecule will be converted into the H positive ion and OH negative ion. Now, the equilibrium constant, if you do remember, Kc is equal to the concentration of the products divided by the concentration of the reactants. Because H2O is actually very large, so we will create a new equilibrium constant. So we will say Kc and H2O. You have H positive ion and OH negative ion, and that will be converted into Kw, H positive ion and OH negative ion. Now, the value for Kw at 25 degrees centigrade, at 25 degrees centigrade, the room temperature, and the standard is Kw is equal to H positive ion concentration into OH negative ion concentration, which is equal to 1 into 10 to the power minus 14. If you want to find out the concentration of water, so the concentration of H positive ion from this formula is pretty easy and straightforward. All you have to do, because both are actually in the same concentration, all you have to do, you have to divide it by 2, so you will get 1 into 10 to the power minus 7. So the concentration of H positive ion is 1 to 10 to the power minus 7. If you take the minus log of 1 into 10 to the power minus 7, you will get the pH of water, which is around 7, nearly neutral. Now let's take an example of water, how we can calculate the pH of water at 50 degrees centigrade where Kw is already given. So if we start with the formula, which is actually Kw is equal to H positive ion concentration and OH negative ion concentration. At 50 the Kw is given. If I rearrange this equation, H positive ion, because they both are equal, the value which is given 5.46, 5.467 10 to the power minus 14. For H positive ion you have to half it, and that will be 2.34 10 to the power minus 7 moles square, moles per dm cube, because it is going to be half now. And if you now take the pH, that's gonna be minus log of H positive ion, which is actually minus log of 2.34 10 to the power minus 7, and you will get 6.6. In this case, that tells you it is still close to the neutral. So even at 50 degrees centigrade, yes, it will change somehow from 7 to 6.6. That means more molecules will be dissociated at 50 degrees centigrade, but still it is close to neutral. Thank you very much for watching my video. The next video will actually be about the weak bases and buffers. Thank you. Bye bye.